Calculus is a branch of mathematics that studies how things change. It helps us understand motion, growth, and areas under curves. Whether you realize it or not, calculus is everywhere, from the way planets move to how your phone processes signals. In this video, we'll break down the core ideas of calculus, making them simple and approachable. We'll start with the basics, explore key concepts, and see how calculus applies to real life. Get ready to discover how calculus shapes the world around us and why it's such a powerful tool for science and engineering. Story of calculus begins in the 17th century with two brilliant minds, Isaac Newton and Gottfried Wilhelm Leibniz. Both independently developed the foundations of calculus, though their approaches were slightly different. Newton focused on motion and change, while Leibniz emphasized notation and general methods. Their discoveries revolutionized science, allowing us to describe the physical world with mathematical precision. Today, calculus is a cornerstone of mathematics, physics, and engineering, and its influence continues to grow. Calculus is divided into two main branches, differential calculus and integral calculus. Differential calculus is all about rates of change, how fast something is moving or growing at any given moment. Integral calculus, on the other hand, deals with accumulation, like finding the area under a curve or the total distance traveled. These two branches are deeply connected, and together they form the backbone of calculus. Throughout this video, we'll explore both branches and see how they work together to solve real-world problems. The heart of calculus is the concept of a function. A function is a rule that assigns each input exactly one output. Think of it as a machine. You put in a number and out comes another number. Functions can describe everything from the path of a rocket to the growth of a population. In calculus, we use functions to model change and analyze patterns. Understanding functions is the first step to mastering calculus, so let's take a closer look at how they work. Limits are a fundamental concept in calculus. They help us understand what happens as we get closer and closer to a certain point. For example, what value does a function approach as the input gets very close to a specific number? Limits allow us to handle situations where direct calculation isn't possible. They're the foundation for defining derivatives and integrals. By mastering limits, you'll unlock the door to the rest of calculus. Let's visualize limits with a simple graph. Imagine a curve approaching a certain value as it gets closer to a point on the x-axis. Even if the function isn't defined exactly at that point, we can still talk about the value it's getting closer to. This visual approach makes the abstract idea of limits much more concrete and helps us see why they're so important in calculus. Derivatives are all about change. They measure how a function changes as its input changes. In everyday terms, a derivative tells you the rate at which something is happening, like how fast a car is moving at a specific moment. In calculus, we use derivatives to analyze motion, growth, and many other processes. The concept of the derivative is central to differential calculus, and it's one of the most powerful tools in mathematics. There are several ways to write derivatives, but the most common are Leibniz's notation dy/dx and Newton's notation f(x). Both notations express the same idea, the instantaneous rate of change of a function. Understanding these notations is essential for working with derivatives in calculus problems. One way to understand derivatives is by looking at tangent lines. The derivative at a point gives the slope of the tangent line to the function's graph at that point. This slope tells us how steep the curve is and in which direction it's heading. Tangent lines are a powerful visual tool for grasping the meaning of derivatives. To calculate a derivative, we use the limit definition. This involves finding the slope of a secant line as the 2 points get infinitely close together. While the process can seem technical, it's the foundation for all derivative calculations. With practice, you'll become comfortable applying this method to a wide range of functions. There are several rules that make finding derivatives much easier. The power rule, product rule, quotient rule, and chain rule are essential tools for working with complex functions. By mastering these rules, you'll be able to tackle even the trickiest calculus problems with confidence. Derivatives have countless applications in science, engineering, and everyday life. They help us find maximum and minimum values, optimize processes, and model real-world phenomena like speed, acceleration, and growth rates. Understanding how to apply derivatives is a key skill for anyone studying calculus. Integral calculus is the other main branch of calculus. While derivatives focus on rates of change, integrals are about accumulation, adding up small pieces to find a total. Integrals help us calculate areas, volumes, and many other quantities that involve summing infinitely many tiny parts. The integral sign, integral, was introduced by Leibniz and is used to represent the process of integration. The notation includes the function to be integrated and the limits of integration if we're dealing with a definite integral. Understanding this notation is crucial for working with integrals in calculus. One of the most common uses of integrals is finding the area under a curve. By breaking the area into infinitely small rectangles and adding them up, we can calculate the total area even for irregular shapes. This idea is at the heart of integral calculus and has many practical applications. There are two main types of integrals, definite and indefinite. A definite integral calculates the total accumulation between two specific points, while an indefinite integral represents a general formula for accumulation. Both types are important, and knowing when to use each is a key part of calculus. The fundamental theorem of calculus connects derivatives and integrals in a powerful way. It states that differentiation and integration are inverse processes. This theorem is the bridge between the two main branches of calculus and is one of the most important results in mathematics. An antiderivative is a function whose derivative is the original function. Finding antiderivatives is the main task in indefinite integration. This process allows us to reverse differentiation and solve a wide range of calculus problems. There are several techniques for finding integrals, including substitution, integration by parts, and partial fractions. Each method is suited to different types of functions. Mastering these techniques will help you solve more complex calculus problems efficiently. Integrals are used in countless real-world applications. They help us calculate areas, volumes, work, and even probabilities. Engineers, scientists, and economists all rely on integrals to solve practical problems and make predictions. Calculus is essential in physics. It helps us describe motion, forces, and energy. From the trajectory of a ball to the orbits of planets, calculus provides the mathematical language for understanding the universe. Without calculus, modern physics would not exist. Engineers use calculus to design structures, analyze systems, and optimize processes. Whether it's building bridges or designing circuits, calculus helps engineers solve complex problems and create innovative solutions. Economists use calculus to model growth, optimize profits, and analyze trends. Calculus helps them understand how small changes in one variable can affect an entire system. It's a powerful tool for making informed decisions in business and finance. In biology, calculus is used to model population growth, the spread of diseases, and changes in ecosystems. It helps scientists understand complex processes and make predictions about the future of living systems. Computer scientists use calculus in algorithms, graphics, and machine learning. Calculus helps optimize code, analyze data, and create realistic simulations. It's a key part of many cutting-edge technologies. Limits aren't just abstract math, they show up in real life too. For example, when you pour water into a glass, the level approaches the rim but never quite spills over until you add just a bit more. This idea of getting closer and closer without reaching is what limits are all about. The derivative gives us the instantaneous rate of change. Imagine driving a car and looking at the speedometer. It tells you how fast you're going at that exact moment. That's what a derivative does for any changing quantity. In calculus, slope isn't just about straight lines, it's about how quickly a curve rises or falls at any point. This rate of change is what makes calculus so powerful for analyzing motion and growth. Calculus helps us solve optimization problems, finding the best or most efficient solution. Whether it's maximizing profit, minimizing cost, or designing the fastest route, calculus gives us the tools to make smart decisions. Related rates problems involve two or more quantities that change together. For example, as a balloon inflates, both its radius and volume increase. Calculus lets us relate these rates and solve for unknowns. In physics, calculus describes motion. The derivative of position gives velocity, and the derivative of velocity gives acceleration. This chain of relationships helps us understand how objects move and change speed. Integrals help us find areas and volumes, even for shapes that aren't regular. Whether it's the area under a curve or the volume of a rotating object, calculus provides the tools to calculate these quantities precisely. In physics, integrals are used to calculate work and energy. For example, finding the work done by a variable force requires adding up tiny amounts of work over a distance. Calculus makes these calculations possible. Calculus is used in probability and statistics to find probabilities, expected values, and distributions. Integrals help us calculate the likelihood of events and analyze data in fields like science, business, and social science. Differential equations involve unknown functions and their derivatives. They're used to model everything from population growth to electrical circuits. Solving these equations is a major application of calculus. Calculus also deals with sequences in series, ordered lists of numbers, and their sums. Infinite series are especially important for approximating functions and solving complex problems in mathematics and science. Taylor and Maclaurin series are special types of infinite series that approximate functions using polynomials. These series are powerful tools for solving problems in calculus, physics, and engineering. Improper integrals deal with infinite limits or unbounded functions. They're used to calculate areas and probabilities in cases where regular integrals don't apply. Mastering improper integrals expands your calculus toolkit. Calculus isn't limited to single variables. Multivariable calculus extends the concepts of derivatives and integrals to functions of several variables. This branch is essential for fields like physics, engineering, and economics. Partial derivatives measure how a function changes with respect to one variable while keeping others constant. They're a key tool in multivariable calculus and are used in optimization and modeling. Double and triple integrals extend the idea of integration to 2 or 3 dimensions. They're used to calculate volumes, masses, and other quantities in higher dimensions. These tools are essential for advanced applications. Vector calculus deals with vector fields and operations like divergence and curl. It's used in physics and engineering to describe fluid flow, electromagnetism, and more. This branch builds on the foundations of single-variable calculus. Calculus isn't just for scientists and engineers. It's used in medicine, economics, architecture, and even art. From predicting the spread of diseases to designing beautiful buildings, calculus helps us solve problems and create new possibilities. Learning calculus can be challenging, but with the right approach, anyone can master it. Practice regularly, focus on understanding concepts, and don't be afraid to ask questions. Use visual aids and real-world examples to make abstract ideas concrete. Calculus is one of the most powerful tools in mathematics. It helps us understand and shape the world in ways that were once unimaginable. Whether you're solving equations, modeling systems, or exploring new ideas, calculus opens doors to endless possibilities. Keep exploring, keep learning, and let calculus inspire you to see the world in a new way.